Hello Internet, today we're returning to a relatively old project on the channel. I started this one about a year and a half ago. This is Asteroids VR. I've been doing a lot of the development myself, just to kind of move things forward because there's a lot to do. It's a full game, and VR stuff is hard to record because if I put like my headset on, you guys can't see anything. So that's not really that useful. So we're just gonna leave that there. And hopefully the goal here is to actually get some work done on getting grappling working. So this is sort of the example scene that I've been working with. This one doesn't work. I've been running into a lot of issues. VR development makes me not like developing games. It's similar to phone development, I guess, in that way. For some reason, whenever I try to sit down and try to do like a mobile game, it frustrates me a lot, and then I just stop for days just because I don't like it. This is similar, but for different reasons. It's just really hard to. There's so many components, and it's just so hard to get them all together. And there's a lot of like just active stuff. Like you're trying something, then you put the headset on and you go and actually test it. It just takes a long time. So that is not so good. We're going to hopefully skip most of that and not use this scene. We are going to use a different one. I think it's the control test area. So I've been working with this scene to just kind of create this giant thing. So this is sort of the test scene that has none of the other fancy stuff. It just has a whole bunch of obstacles of different sizes. So we've got different sized ramps. Lighting is still being baked because I just switched scenes. We've got some stairs, though there aren't probably going to be any stairs in the game, but there's a whole like spiral staircase thing. It's a 6 degree of freedom game, which means you can control your yaw, pitch, and roll as well as your X, Y, and Z. So you literally get to like fly and flip over. So some of these curves and stuff will actually make that possible. These are kind of like a gimbal and they'll actually rotate. So it's all just different control things because I kind of wanted to just play with them. The big problem with this project has not been making it. It's just Asteroids, like the classic Atari game or whatever. The problem has been how do you do it and not make somebody just sick? Because you can literally flip over. I have a private video that I'll link here, and it kind of demonstrates like flying the way that it is right now, and it's pretty cool. You can like do flips and stuff and actually control it, but people get motion sick in VR just from like standing in place, and this is literally standing in place but also flipping you over on your head and doing barrel rolls in space, which is awesome, like really cool, just not not always great. So hopefully this scene works. For some reason Unity just crashes. It doesn't actually connect to Steam. So should be able to start this. We should get connected, and I should actually be able to kind of walk you through some of the controls. I think it's pretty cool. I don't think anybody has done this stuff before. So we're going to give it a try here. I think we're connected. So I'm actually not going to touch the headset. So these controls are going to be in the wrong orientation. My headset's facing that way. I'm facing this way. But the way this works is there's grip buttons here. I don't know if you can see that, but those are on both controllers. And so if you hold those and twist, it works sort of like a steering wheel, but a 3-dimensional steering wheel. So it draws a line between them, and then you can pull it around. So if I tilt down or tilt up, it does it. It's reversed because I'm reversed, but you sort of get the idea. It gives you a way to do 3-dimensional rotation and stuff without doing anything fancy. And then you can pull the triggers to actually accelerate yourself. And you can do that at the same time too. So you can control yourself or fly into that thing, and then fly away. So you get the idea. There's also a button, I'll put this here, where if I press the menu button up here, that is actually going to spawn this thing. That's what we're going to be getting working. So I'm using some of the Bezier curve stuff that we had working in previous videos, and then just a bunch of springs to get this whole thing working. So there's a spring on the end and a spring in the mid or at the other end, and then it draws a Bezier curve between the two, and you sort of get that whole fancy thing. So what we need to do is attach. It's losing tracking because my entire VR setup is like just moved around, but it should be fine. So we need to get that little end to attach to the controller, and we need to make it not spawn at a 90-degree angle, and we need to get it to actually shoot up and stick to things. It's probably going to take a bit, but we'll see. I just kind of want to get it done. So we're going to let it continue baking lighting because that's always fun. And we're going to jump over to our... Where did I put that? Everything is getting turned upside down. All right. Did I really do that? Hold on. No. Okay. Where did I... Tools? Okay. So I should point out, I haven't come to this project since my VR setup has been down for like a month. So I've kind of misplaced things. Don't know why I called it tools. I guess I was thinking there'd be other tools other than a grapple. Yeah. But now that we have this, we have a grapple. It's got actually 4 points and a line render that it actually does. So we actually have one right here. And so this one just kind of spawns statically. But we have just 4 anchor points. You can see all but one of them has a spring joint connected to it. And they just go up the chain. So anchor point 1 is connected to anchor point 2. Anchor point 2 is connected to anchor point 3. And anchor point 3 is connected to anchor point 4. And so all of those make our spring chain thing. And so theoretically that will connect you to something, and then you can adjust these springs to actually pull the player towards whatever it is. At least that's the idea. So here is the cylinder. Probably the easiest thing to do is just rotate this 90 degrees. I don't know if this is actually the correct orientation. We can play with that. But that's really all we need to do to get it oriented in the correct direction. And then we can actually just shoot it based on that. I think that makes sense. For now, I'm not really concerned with creating a mesh or anything for it, so that may all change, but I think we should be able to just work like that. So if I run this again, because that's where we're at, should be able to spawn, get a controller. That's still not right. So we should be able to, well, that didn't even change. Let's try that. There we go. So now if I spawn, these are all kind of in the same place, but if I were to spawn there, you can see it's in line with the controller. So if I point towards you, it would shoot into the camera, which is exactly what we want, because if it's doing that, it means it goes forward. So now we just need to make it go along that axis, whatever axis that is. I think, there we go, our light's baked. Cool. I think this should be the z-axis, which is perfect because that's actually what we want. Z is going to be the forward vector, which means we can actually move this forward, attach our other anchor point to our player, and then everything should hold together. At least that's sort of the idea I'm basing this whole thing off of. And so we need to attach this anchor point 4 onto, let's see, we're going to need to attach anchor point 1 onto our player's controller. So there is a spawn point for the grapple. One of these needs to be attached, either the 4th or the 1st. The 4th one is not dynamic at all, and it's already going to be attached to the object. So we're actually just going to use the first one, and do things that way. Because we're going to do that, I can actually take off this spring component here. We're not going to need that. And then we'll save, apply that. And then just for testing, I'm gonna create a really quick projectile script. So we don't have one now, so let's actually just do that. Projectiles, sure. And we'll just say projectile thruster. I guess that makes sense. We'll rename it later. That's probably not the best name for what this is actually going to do, but effectively it's going to, given a speed, it's going to move something along that. And that's it. We don't need it to do anything else. It doesn't need anything fancy, no physics, no nothing. It's strictly just going to move it, and then we'll have another component that will actually handle updating it, and it's probably going to be actually attached to the controller. So this should get all started up. And then this should be really straightforward. We just need a public float with a speed and void fixed update. This is a physics component, so we're going to do everything in the fixed update just because that's where physics gets updated. So this way it gets updated with all the other physical stuff instead of updating independently from it. That might cause some issues if we didn't do that. So all we need to do for now, this might not work later. We may start needing to use rigid bodies for this, but right now we don't. So we can just increment this and just kind of move it forward on its own forward vector times the speed times the time delta. So this is just going to, that's not the right time delta, fixed delta time. There we go. So this is going to take its forward vector and move it along that at some fixed velocity. And that should be everything we need to actually get this moving. We'll set this to something really basic for now. Class can't be found. Of course it can be. Oh, it hasn't compiled yet. So once that happens, like that, we should be able to add this, give it a really small speed, apply that. And then I'm just going to disable the one that's already there, just so it doesn't cause any confusion. And now, theoretically, we should be able to put this in front. I'll try to angle it in line with the camera, sort of. And it's moving, not in the correct way, because it's still attached to the same thing. So because it's attached or parented to the other object, it's just going to fly with it. We don't want that. So the idea here is instead of having a grapple point 1, we're going to swap that out and make this first point in our Bezier curve renderer actually be the anchor point for the player. So I shouldn't actually even need this. And nothing else references it, so I'm going to keep it for now. We might just get rid of it later. So that is handled in this grapple launcher, which actually creates everything. This is part of VRTK, which is a VR toolkit for actually making VR games. It gives you some really nice ways to actually handle like button presses and things like that, which you normally would have to build yourself or build for a specific platform. This is cross-platform, so it will target like Windows Mixed Reality, Vive, and Oculus, which means you can develop once and kind of put it everywhere in a relatively easy way. I've only tested it on the Vive, but it's worked pretty well so far. So what we need is we have this fire script. This is actually going to shoot off our projectile. We need to get that Bezier curve renderer and actually attach something to it. And so the way I think I'm going to do this is with messages. And so the idea here is we're going to have our projectile that we're going to spawn. So this is going to give us our game object back. I want to send a message to that, which is going to be in send message. So send message is going to call a message, or it's going to call a function on any component in that game object if it exists. So similar to like onCollision would send a message and say, hey, there was a collision and this is what hit it. we can do the same thing here and actually say, hey, I fired this projectile, and here's where I fired it from, or here's some of the parameters I fired it with. We're already spawning it with a position and a rotation, which is what we need. We already have the speed, but I need to know what to anchor it to. And so that's sort of what we're going to try to do here. I'm going to send a projectile fired event with a this transform position. Let's actually give it the transform itself. And that way we should be able to track that and keep it up to date in the Bezier curve. I think that makes sense. We'll see. Kind of making that part up as I go. But theoretically now, if I were to attach this, for now, we can just throw it on the projectile thruster. So if I do a void projectile fired transform of the origin, if I could actually type, there we go. And so what I want to do is get a component called our Bezier curve render, and I want to set the something of it. We want to set the points 0 to be, I actually wanted that, there we go, to be equal to our origin. So this should replace that original 0th position with the new point that we just added. And so hopefully, instead of this anchor point 1, we're going to get our controller point, which means even as I move the controller around, it should stay attached to that. And so it should spawn in that general direction, sort of right near the top of the controller, because that's just where it spawns from. But I think that makes sense. Hopefully it all works. And if not, then oops. But we shouldn't need to change anything. We just added a message call. So I don't think there's anything we have to change. We'll find out if this works. Our rope, our grappling hook, will actually stay connected to the controller. And it does. Aha! And it curves and everything. That's cool. It's kind of off to the side. That's sort of because all the stuff is incorrectly rotated, but you sort of get the idea. This will just go on forever, but now we have a way to actually do that. The only other thing I need to do in order to make this actually really do things, well, there's 2 bits really. One, this isn't going to pull the player at all. There's no logic here to pull the player. I'll probably do that separately because that might be its own giant problem. But also, that projectile doesn't have a max distance, and it doesn't ever stop if we shoot it through something. Like if I go over there, and I can shoot multiple of them. But it will just go through that wall without any problems and just keep going. That's probably not good. It kind of defeats the purpose. So let's fix that. All we need to do is add some collision detecting on this, and it should work. But yeah, I don't know. I'm pretty happy with that. It looks like a rope. So I don't know what else I was expecting. All right, projectiles. I think we're just going to have a maximum distance limiter. And for now, I'm just going to delete the projectile if it goes too far. And that's probably not the correct thing to do. It's not going to look good, but it's going to be fairly easy to do. And so for now, that's a good starting point. We can spice it up or add cool other things later. For now, just max distance equals, say 10. We can change that later. And then I need a private variable for my origin. Vector3 origin position. So the idea here is the start. We're going to initialize our origin position to our starting position. And then every update, we're going to check if the origin position and the current position are longer than what it was. We could put this in our actual thruster and keep track of the distance traveled that way. But this way we can have sort of these two things separate. It'll be a little bit more expensive, but I'm not, if we run into performance issues, we can optimize it then. For now, kind of separating these things out just makes more sense, and it makes them more reusable. So let's do that. Add a position, and then we're updating everything in the fixed update anyway. So let's do it in the fixed update. And so if the origin position minus the transform position dot magnitude, it's not popping up because I've done this wrong, but there we go, is greater than the max distance, then we've exceeded it and everything's going to break. So there we go. We'll just destroy this .game object. Cool. And we'll print something out that just kind of gives us a hint that we exceeded our distance, just so I know what's going on. Maximum range exceeded. Sure. And so that should handle the maximum distance issue. We should be able to just shoot these off and they'll run into their max distance and stop. So let's attach that onto our grapple, like so. And we're probably going to speed up the projectile thruster now that we know that it actually works. And so max distance, we'll say 50. I don't know if that's a good number, but and then max speed, we'll say, when I had this working previously, this isn't the first time I've added grappling hooks to this game. We kind of did a little bit of it previously. This one is hopefully better. The problem that I was running into was you need them to be fast because it's really hard to aim. And if they go too far, it just gets really hard to predict them, especially in asteroids, because the entire environment is moving. So it really helped if they were short range things that moved really fast, so you'd fire them really quickly. They'd have a little delay, but not too much. So hopefully this kind of gets us to that point. I'll tweak these all afterwards, but it doesn't really matter. There we go. So that should go out, and then the rope should disappear. There we go. So we know that the max distance thing is at least doing something. We don't necessarily know that it deleted it at 50 meters like we had said, but it did delete it, which is good enough for this. So the final thing is going to actually happen here, I think. And we are going to track our distance. And so here, we're just going to add on the distance, which I haven't changed anything here. There's no differences. The thing that is different is I actually want to be able to do a raycast here. We could handle this with a rigid body collision, like a sphere collision. Is that a good idea? So what I'm thinking, there's two options. We could do a raycast and actually shoot it forward the distance we're going to travel, or a little bit more, to kind of see if we hit anything. The alternative is to use a sphere collider. Why do these have sphere colliders on them? They probably don't need sphere colliders on them. I think those were there so that they would kind of bump and they wouldn't overlap, but we can probably take those off. And so the idea here would be to put a sphere collider on the grapple itself, and then when it would hit something, it would trigger and stop it. So I think we should be able to just drop those without any issue. So let's do that. Those can go away. And let's add a sphere collider. Do I want it to be a sphere? Maybe not, but we started with a sphere. We'll work with a sphere. Now this is really small, which isn't great for this. So we probably aren't going to get much success with this method. The problem with it being small is collisions are detected at the intersections, if that makes any sense. So if there's a wall here, like a plane, if we were to move this entire object through that plane, like it's on one side and then it's on the other, if we do that, this won't detect anything. You can fix that with a rigid body and have all the movement be handled in a rigid body, which actually may be a good idea. And so just to kind of give you an idea of what that would be, there's a rigid body and then there's a collision detection. You can turn on continuous or continuous dynamic collision detection. They're slower, but we can have a maximum of 2 of these things ever, 1 per each hand. So theoretically, you could enable continuous dynamic, which means it will continuously check for collisions instead of just checking at the end of the frame if there was a collision. So this would get it to work. We would have to rework how our thruster is working. It would have to apply rigid body force and actually move the rigid body instead of the other way around and just changing the transform. But that would get it to work. If we don't do that, we risk like shooting through things unless we do a ray cast. So not sure what the best option is. I think we're going to go with the rigid body though, because I think that makes the most sense right now. I could be wrong. We'll figure that out when it turns out I am. But for now, I'm going to turn off gravity. I'm going to make it, do I want it to be kinematic? Probably. So we'll make a kinematic rigid body that is continuously detecting collisions. The mass shouldn't really matter. It's a kinematic rigid body, so it's not really going to do any crazy stuff. We do need to change this projectile thruster. This isn't going to work. So, private rigid body. Rigid body. There we go. And we'll need a start again. There we go. Rigid body equals get component rigid body. There we go. And let's just require a component of type rigid body. This is just going to actually make it so that we actually need that type. Unity will automatically add it if we don't have it, which is kind of just a nice safety check. It's sort of an editor level advancement thingy-majig. Very technical. So now that we have that, we should be able to take out some of this stuff. So instead of doing all of this fun stuff, let's do rigid body dot add force, add velocity. Velocity equals this. So we don't need the fixed time delta anymore. That's not really required. This isn't going to work if we're doing it with a kinematic body though. Kinematic bodies mean they simulate their own physics. They do their own stuff. So I think we can just take this off. Do rigid body dot set dot is kinematic equal to false. So this will just force it to be non-kinematic. Otherwise, it wouldn't move anyway. It doesn't really make any sense. So this will just be sort of a check to kind of make sure that everything's good. And then we'll force the velocity to be something. And then shoot it off. This is going to make it bounce, which isn't really what we want. We're going to need to actually add some collision detection here to actually stop it. That's going to be handled in a separate component that's actually just going to kill the thing and orient it to whatever it hits. So I'm kind of picturing it like you shoot at something, it hits it, and then it rotates or something, so that's facing directly into that. And that might not be the best, but I think it will look all right, and it will prevent any weird other behaviors. So theoretically, that's all I needed to do. We have a rigid body, and everything else should be working. Hopefully I didn't miss anything. So now that I've applied that, it all should work, right? Or not. Let's find out. So if I shoot that wall, track, there we go. Well, it bounced. Oh, that's kind of weird. It trails behind. That's not really what I want. So the bouncing works. Not really that bouncing was the goal, but the bouncing works. So that's a win. So the next thing is going to be to figure out why that was happening. Why was it bouncing like that? I don't know. Done. Cool. Problem solved. Yeah, I have. Do I have an idea? I might have an idea. Oh, was I supposed to change the other one? I might have been supposed to change the other one. So it might have been that anchor point 1 was actually the one attached to the projectile, and anchor point 4 wasn't. Now that we're simulating everything with rigid bodies, these should actually kind of spread out. That's my understanding, at least. I could be totally wrong there. My knowledge of Unity physics is not the greatest, but I think I just fixed it. Nope. All right, well, that was a failure. Great, we're good at those. Let's see here. What did I do wrong? So anchor point 1 and 4 are both kinematic, which should mean that they're both anchored to this grapple. That was sort of the general idea. And so what I was thinking would happen is that we would have 1, which is the player, 2 and 3, which are in the middle somewhere. They can kind of flop around and do whatever. It's all spring stuff. And then the 4th would be attached to the projectile, which should just track it, right? That was the grand idea. That final bit isn't happening. And I don't know why. It might be a problem to solve later. But I would imagine making it kinematic would hold it onto whatever it is. That was sort of the grand idea. But it clearly didn't work. We could fake it. So I could swap out this anchor point 4 with our grapple anchor, which will actually like force it to be attached to this cylinder itself. That will fix it, but it could cause other issues, I think. Yeah. So you can kind of see that works. And you can see the cool physics, like the rope wobbles because of the Bezier curve stuff we're doing, which is sweet. And the way that I had this working in the previous game was you would hold the button and it would shoot off, and then when you release the button, it would stop. The cool thing with that is you could like swing around an asteroid and then release on the other side, and you could kind of maneuver yourself through them instead of it just always pulling you directly to it. That isn't always what you want. You could use them to like swing between things. So I think we're going to get that working as well. I might just do that on my own time because it's literally just release the button, delete the projectile. But the only other real thing we have to do is detect a collision and then stop it, which is literally just make it kinematic when it hits something. That should be it, right? So we can do that now. Let's see here. Force stop projectile. Another great name. I don't like these names, but that's fine. Void on trigger enter. That's cool. What's adding that? That didn't used to happen. Something suggesting Unity names. I think that's some Visual Studio thing, because I don't have ReSharper installed right now. I don't think NDepend would do it, so cool. I didn't know that. So this is going to give us whatever we hit. I'm actually going to, well, this is actually only going to happen once. So we're going to actually do this on collision. We're actually going to stop the projectile, which means we need to get the rigid body. Rigid body equals this get component. We'll grab the rigid body. Rigid body dot is kinematic equals true. And this dot transform dot position equals other dot point. Actually, no, the collider is not going to give us any of the information about where we hit. So the best we can do is just turn kinematic stuff on and then just stop. This will only work if we enable our grappling hook to be a trigger. And there's some other things. We're not testing anything, which means if I do this inside the player, because the player has a collider, this will just hit the player and stop immediately, which is actually a problem that I had previously. We're not going to solve that here. That's just some masking rules. So you can check different layer masks. We could just not check the one the player's on and check like the asteroid one. That would solve it, but it's just an extra step that isn't really worth it. So for now, I forgot to disable that one, but there we go. Or not. That didn't work. What did I do wrong? Not add it to the projectile. That's what I did wrong. So we actually need to take this force dot projectile thing that we wrote and actually attach it to our script or to our projectile. That's actually required. I really like the fact that it breaks my my prefab if I move things around. That's a nice feature. Let's apply this. There we go. Restore the prefab. Disable it this time, so it doesn't just break all over. And now we should be able to shoot a wall. And it sticks. Cool. Huzzah. Okay, so we have a projectile that kind of grabs on. And now I just need to add force. Not going to do that in this video. There's a whole bunch of different ways to do that. So we'll just leave that for another time. But that's basics of shooting a rope and having it hit something and do stuff in VR. Nothing really specific to VR here, just I'm doing it for a VR project, so it's in VR. That's one of the nice things, I guess, of like Unity. And most of the stuff, like 90% of it, is not specific to VR. There's no real VR stuff. Some of it was. The grapple launcher does have some stuff that is VR specific, like VR TK is doing a whole bunch of stuff to set up the scene and connect all these controlling events, things like that. You don't have to do that in a normal game, depending on your input manager, I guess, but you don't normally have to do this stuff. So yeah, other than that, it's pretty straightforward. So I'll leave it here. We'll get to doing the other grappling hooky stuff in the next video. So until then, see you, internet.